Hello and welcome to the lecture about the implementation of the linked list. During this lecture, I will teach you how to create a linked list step by step with code. Let's dive into the lecture. First of all, let me discuss the code necessary for implementing a linked list. Please don't worry, code may seem a little bit confusing, but I promise you that it will get easy to understand in the end. First, we have a class called node. Very simple. The initializer or init method just contains two elements, a data point to be stored by the node and the address of the next node. Why initially the next is none? Because we consider it as the last node. Therefore, the last node always indicates none. Therefore, if you're going to add a new node to the linked list, then the second part of the previously inserted node will be updated. The next data structure we're going to create is the linked list, which is a wrapper that wraps over the nodes. The node class would also be a subclass of the linked list. We have a constructor, and the constructor always will have a head node inside the linked list. As I have mentioned earlier in the introductory lecture about the linked list, the head node contains no data and only has the address of the first node within the linked list. Moreover, we have two other methods, insert and print, which I'm going to discuss later. Here I have provided a simple and quick overview of how a linked list is created by the linked list class. But to give you a deeper understanding of how the nodes and the chain-like structure are created, I will talk about all the necessary details. This is an example-based course, and I do believe that without taking an example in action, it is not efficient to learn something new. Therefore, let's dive into code step by step. First, we must create an instance of the linked list class. Whenever we create an instance of a class, then the init method will be executed automatically. More specifically, every time an instance is created from a class, then the init method is called. Self also represents the instance of the class, and it's a way to access the attributes and methods of the class. Therefore, here the initializer will have the head by initially assigning none to it. The head contains no data but only points to the first node within the linked list. Now let's move on by adding the first node to create the linked list. To this end, we must call the insert function, and we pass 55 as the argument. Please keep in mind that this function will add a new node to the end of the current list. In the next line, we must use the node class to create the new node. We use 55 as the data and set none to the next of the node. As is observed, the new node is created and we have the head, but there is still no link between them. Proceed with code, and now before going to the next step, let me clarify something. When we create the first node, then we must assign it to the head. Therefore, let me remove these lines of code and bring the last line to the above. This line of code is defined to assign the first node to the head. Here, it probably makes sense to assign the new node to the head, but what if there are other nodes within our linked list? More specifically, we're not sure if a node has already been assigned to the head. Let's take an example in action. Suppose a node has already been assigned to the head, and now if we assign another node to the head, therefore the previously assigned node will be excluded from the chain. Accordingly, before assigning any new node to the head, we must make sure that there is no node within the linked list. So we need if condition to check it out. Let's bring back the code by putting the lines of code in their correct order. As mentioned earlier, we need a condition to check if a node has already been assigned to the head or not. If head is equal to none, we can conclude that there is no node assigned to the head yet. Here, the condition is true, meaning that the head is pointing to the none. Therefore, the new node can be assigned to the head. So go to the last line to assign the new node to the head. Now the linked list is just created. Let's add another node. Call insert function by passing 11 to it. The corresponding node will be created by using node class. For the data part, we put 11, and for the next or reference, we put none. The new node is created, but still there is no link between the new node and the linked list, so it's the time to find the last node to use its reference for putting the new node in the linked list. And now move on to find the last node. This if condition checks if the head is pointing to a node. If yes, meaning that a previous node is assigned to the head. Therefore, we must assign the new node to the next of the previously assigned node, that is none for now, but we should update it soon. To traverse the linked list, let's assign the head to a variable called current. Go to the next line to initiate the while loop. It says, okay, if the next of the current is not equal to none, then go to the next node to find a node whose next is none. Otherwise, assign the new node to the next of the current node. The condition is not true because the next of the current is none. Current node here is first node. Therefore, we assign the new node to the next of the current. Now, the new node is included in the linked list. And finally, let's add another node. Let's add the last node by calling the insert function and passing 20 into it. In the first line of the function, we must call the node class to create a node with the data part and the next part. We put 20 as the data part and again none as the next or reference part. Go to the insert function. Again, we must check if any previous node is assigned to the head or not to make sure that the linked list is not empty. We assign head to the current and then go to the next line to traverse the linked list to find the last node. The next of the first node is not equal to none. Therefore, the condition is true. Go to the next line within the while loop and update the current, meaning that we must check the second node. Now the condition is false because the next of the second node is none. Therefore, we assign the new node to the next of the second node. That's it. We created the linked list by including all nodes, and now it's the time to show how print function works step by step. Let's move on to print out the linked list by calling the print function. In the first line, we assign head to a variable called current. We use this variable to iterate over each node in the list starting with first node. And in the next line, check if the current is not equal to none. The condition is true, therefore go to the next line to print the data part of the node. and then in the next line, update the current to indicate the second node. Therefore, now current indicates the second node. Check the condition if the current is not equal to none. The condition is true, and then go to the next line to print out the data part of the second node. And go to the next line to update the current in order to indicate the third node. The current is not equal to none yet, meaning that the condition is still true, and then go to the next line to print out the data of the third node. Finally, go to the next line to update the current, and this time the none is assigned to the current. It means we have reached the last node. Go to the while loop, but the condition is not true anymore because the current is equal to none. Go to the last line to print out the none. That's all. I tried my best to make the linked list as simple as possible, and I hope you enjoyed learning. Thanks for watching this video.